So I'll just remind you that this pattern 30525 is just repeated over and over. Okay, now I've pointed out here that, well, this is a string of length 5. Okay, the length of this string is 5. So we've got from this number 5, the distance 1, 2, 3, 4, 5. So it lands here. Okay, so I just want you to keep that in mind as I explain this next part. So now some mathematics, rather than let's say symbolic representation maybe. Rather than drawing these patterns and seeing if two arrows come in at the same place at the same time, we can actually represent or apply this distance rule in terms of symbols. So let's say we have a pattern or a sequence that's represented by these A's with subscripts, okay? So say we've got A0, A1, up to AN, and so on, AN plus I, and so on. Well, the distance rule simply says that if you take the difference between these two numbers, right, so the AN and the AN plus I, so they're a distance I apart, okay, their distance is this guy here, the I. If their distance apart is equal to their difference, right, the difference in the actual numbers, then the sequence cannot be juggled, all right? Because actually what this means is that both balls are going to land in the same hand at the same time, all right? If we have a 4 followed by a 3, all right, so a 4 and a 3, their difference is 1. And if we have a 4 followed by a 3, so their distance is also equal to 1, then they're going to land in the same hand at the same time, okay? So this can be generalized for any sequence as AN minus AN plus I equals that difference between their subscripts. If that's the case, then the sequence cannot be juggled by this distance rule. Okay, we've also got the number of objects rule. So far, I've shown you these sorts of patterns. Okay, I've shown you, say, the pattern number 3. If you remember, there's 3. Okay, here's 2, 3, 4. I'll just remind you. What else do we have? Oh yeah, 1, 5 or 5, 1 is just this one. Okay, and 2, 4 is the boring old, just hold on to one ball across the beats. So there are some examples, but each of these patterns use 3 balls. Okay, is there something inherent in those numbers that tells me that I need 3 balls to juggle those patterns? Well, it turns out there is, and our notation does tell us this. In each case, if we take the average of the numbers, and this is the rule, the average of these numbers, we always get the number of objects that we're juggling. Okay, so let's have a look at this first one. The average of 3 is simply 3. Okay, so that's saying we need 3 balls. Here, 2 plus 3 is 5, plus 4 is 9, divided by the length is 3, so that's also telling us we need 3 balls. And similarly, 1 plus 5 and 2 plus 4 both equals 6. They're a string of length 2. So in general, the rule is that the number of objects with which we're juggling is the average of the pattern. So, for example, just by that simple rule, can I juggle the following? A 5 followed by a 2. Is that possible? Well, by the number of objects rule, 5 plus 2 is 7, and if we divide by 2 is, well, let's say, is not an integer, or is not a whole number. Okay, so since the average of these two numbers is not a whole number, it means I can't juggle it, right? So this is telling me I'll need, what, 3.5 balls, whatever that means, okay? So that's the other rule that we need to impose. This must be a whole number, right? Or it must be an integer. So now we're presented with this problem of, can we use these rules to check if that pattern is possible? All right, well, all right, we can see, we can try and work out what's the average of these numbers. Maybe if it is a whole number, am I able to juggle that pattern then? I don't know. Is that a whole number? I'm not sure. So that's one of the things we can do. So just simply by looking at that, I can ask the question, well, how do I know whether or not I can juggle that? So one thing I could do is first, and in general as a rule of thumb, you could first find the average of these numbers, check that it's a whole number. If it is, then try and apply the distance rule. Remember, the distance rule is saying, for example, if we take this entry here, the 3 and the 2, well, the difference between 3 and 2 is 1, right? Their distance is 1, 2, 3, so 1 is not equal to 3, but so that's okay. But I need to repeat that for every pair of numbers that appear not just in this sequence, but in the sequence that's repeated over and over, right? And so it's very, well, it's not so convenient to apply the distance rule as I have stated it so far. So now it turns out, well, is there an easier or a simpler approach? Now you'll have to remind me, did I ever know this in the first place? The Japanese for the words for these. Now a theorem in mathematics is generally one of the very important results in the discussion or in the theory. Now theorem in Japanese, teiri, is that right? Teiri, okay. And usually when we present a theorem in mathematics, we also accompany such a result with a proof. Now proof is shoumei, right? So we usually in a presentation we have teiri and shoumei, yeah? So a theorem followed by a proof, right? To establish the result. Now this is a theorem known as the permutation test. All right, and it makes life a lot easier in testing whether or not a given string of numbers is actually a jugglable pattern. Jugglable. I don't know, I think I just made up a new word then, but anyway. So let's say we have a sequence of non-negative integers. I think I should make that clear that in these sequence of juggling patterns, all of the numbers representing throws are non-negative. Okay, so I have no definition for a negative throw, right? So if we've got this sequence of non-negative integers, then the theorem says that this sequence is able to be juggled, or is a juggling sequence, if and only if this sequence is a permutation of 0, 1 up to p minus 1 taken mod p. All right, so all we have to do is, however long this sequence is, in this case its length is p minus 1, okay, for some given p. The length of this sequence is p minus 1. So all I need to do is go to the first entry in the sequence, add 0. Go to the second entry, add 1. And so on up to the p minus 1th entry and add p minus 1. Okay, and that's exactly what I've done here. And then take each of these terms mod p, right, mod p. And if that's just a permutation of 0, 1 up to p minus 1, then the result is that I'm able to juggle the sequence. Permutation, is it junretsu? Is that permutation in Japanese? Is that right? No? Okay, anyway. Do you understand what I mean by permutation, though?